In this video, I will show you how to write the standard form equation of an ellipse given various pieces of information. For example, the vertices and co-vertices, or the endpoints of the major or minor axis. Keep in mind that the standard form equation of an ellipse looks something like this. So we need to have a equals 1 on the right hand side, and we need these parentheses squared where the h and k will be the center, and then we'll have these denominators of a squared and b squared, which we will talk about. So we can go ahead and just begin to set up the form of the equation like this. Okay, now let's use the vertices to figure out what the center is going to be. So we have a vertex at -1, -2, so that's going to be right here. And we have a vertex at -9, -2, so that's going to be right here. Now if these are the vertices, right away that tells us that we are looking at a horizontal ellipse. Now the center, of course, will be the midpoint of this segment, halfway between the vertices. So the center of the ellipse has got to be right here. And the coordinates of this point are -5, -2. So I now have the center, -5, -2. That center enables me to create the numerators of my equation. It will be the opposite of each one of these. So because of the x-coordinate -5, I can write x plus 5 squared. Because of the y-coordinate -2, I can write y plus 2 squared. So I have half of my equation done now. But it's even better than that, because this also gives me the a value. The distance from the center to a vertex is the a value, and this distance is 5. So that tells us that the a value is 5, which means that a squared is 25. So because the a value is horizontal, the x direction, then that tells me that the 25 will be in the denominator of the x term. So let's go ahead and use the covertices to figure out what the b squared value is going to be. So I have a covertex at -5, 0. Okay, so -5, 0, that's right here. Here's a covertex. I have another covertex at -5, -4. Okay, that would be right here. We did not even really need the second covertex to answer this question, because as soon as we knew the center and knowing one covertex, that was enough for us to see what the b value is. Alright, the b value is this distance from the center to the covertex. So I can see now that the b value is 2, which means that b squared is equal to 4. And again, because the b value is vertical in the y direction, that tells me that this b squared value of 4 is going to go in the denominator of the y term. And there we've done it. We have the standard form equation of the ellipse that has these characteristics. So notice that they gave us more information than we needed. That will not always be so. So if they were to give us only one covertex, you should still be able to answer the question and find the equation. Let's go ahead and take a look at number 11. So the vertices will tell us the center and the a value. So we have one vertex at 6, 4. Okay, so there's a vertex. We have another vertex at 6, -10. So that's right here. The center is going to be halfway between the two. All right, I'm looking at 10 and 4. That's 14. So if I go down 7, that should be at the center. All right, so this will be the center of my ellipse. Clearly, this is a vertical ellipse with the major axis going from vertex to vertex. My center here is the point 6, -3. That is going to give me the numerator of my equation. So because of the 6, I'm going to have x minus 6 squared in the numerator. All right, because of the -3 y value, I'm going to have y plus 3 squared in the numerator. And it's always going to be equal to 1. This also gives me the a value, which is the distance from the center to a vertex. Okay, and that is 7. So since the a value is 7, that tells me that a squared is 49. Because this a value is vertical, it's in the y direction, this 49 will go in the denominator of the y term. Now, let's use the covertices to find the b squared value. We have a covertex at 4, -3. Okay, we have a covertex right there. I really don't even need the other covertex to finish the problem, because I already know that the b value, the distance from the center to a covertex, is 2. And since the b value is 2, of course b squared is equal to 4. Since the b value is horizontal in the x direction, I'm going to put this 4 in the denominator of the x term. And that's it. This is the standard form equation of the ellipse. Okay, are we supposed to graph these? All right, it just says write the standard form equation. It didn't actually say that we had to graph these, but why not? So there you go. Let's go ahead and scroll down and take a look at number 12. We are given the endpoints of the major axis and the length of the minor axis. That should be enough information. So the major axis means that these are the vertices. All right, the vertices are the endpoints of the major axis. So this is just another way of saying these are the vertices. So let's see, -1, 4 is right here, and -1, -4 is right here. Well, that means this problem is going to be simple. All right. Oh, look, it's up 4 and down 4. That means the center is going to be here at -1, 0. All right, that's not very challenging. So since the center is -1, 0, that tells me that I will have x plus 1 squared, okay, in the numerator from the -1. Because the y value is 0, that means I will just have y squared in the numerator, of course, equals 1. This also gives me the a value, because the a value is the distance from the center to a vertex. So the a value is 4. And if a equals 4, then a squared is equal to 16. Now, because this a value is in the y direction, that tells me that the 16 will be the denominator of the y term. But they also gave us the length of the minor axis, okay, which is 6. All right, that is not the b value. That's twice the length of the b value. Because the minor axis has a length of 6, that means 3 to the right of the center and 3 to the left of the center. Okay, so this is the minor axis. All right, from co-vertex to co-vertex is the 6 that they're talking about. But that means that the b value is 3. And if the b value is 3, that means that b squared is 9. Notice that this b value is horizontal. It's in the x direction. So of course the 9 is going to be the denominator of the x term. And that's it. This is the standard form equation of the ellipse for number 12. I'm going to go ahead and draw the ellipse, even though they didn't say that we had to. Because why not? All right, there you go. All right, let's do one more problem. They're giving us the endpoints of both the major and the minor axes. So of course, plus or minus 7 comma 0 really means we're talking about 7 comma 0 and negative 7 comma 0. So these are the vertices, and we just know that because 7 is bigger than 4. So 7 comma 0 is going to be here, and negative 7 comma 0 will be here. All right, that makes this a little bit simple because the center is simply going to be 0 comma 0. So right away that tells us that the numerator will be x squared and y squared. Okay, also this tells us that the a value is 7. And if a is 7, then a squared is 49. And since the a value is horizontal, it's in the x direction, the 49 will be the denominator of the x term. And the b value is going to be 4. Okay, 0 comma 4, 0 comma negative 4. All right, these are the co-vertices. So since we know that the b value is 4, that means b squared is 16. Since this b value is vertical, it's in the y direction, the 16 will be the denominator of the y term. And this will be the equation of the ellipse. And once again, even though they did not ask us to graph it, I shall. And there you go. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.